Well, hi, Kuant. Hi there. How you doing? Oh, I forgot how big the mini maker is now. Oh, I'm such a big boy. I grew so much. Well then. Hi. How you doing, Kuant? I haven't heard from you in quite some... Oh my goodness, that's loud. Okay, there we go. This should be better. Alright, I didn't play everything. Now it should be everything. There we go. Sweet. Was that? Was what? Was the mini make it? Or what? Hold on, the day number is all funky, isn't it? Isn't day 200, 552? There we go. Wacky day then. It won't be a wacky day, it will be wacky math. For even wackier physics. We're going to be walking the video. Sad I had to come back. You mean come back from camp or come back to my streams? Because I don't know if I don't know if I'm gonna cry, if I should cry or from camp. Okay, good. No, it's fine. I wasn't gonna cry. Anyhow, the number was weird today. Yeah. There we go. I have so much stuff on my... Oh yeah, I've been prototyping on my walking desk. Well, we're done with the prototyping streams for now because... Why is the music so loud? Well, we're done with the prototyping streams for now because no one seemed to like them. So we're back to the... you know... We're back to the walking streams where we walk. Isn't that fun? Now I'm legally qualified to use those fancy VHF radios. Wait, you need qualifications for those? Whoops. I mean, no, I never broke the law. I would never. Anyhow. What shall we do today? Oh, I'm so glad no one asked. You see, today we will be working on a video called Breaking Physics Using Math. Hence the title. Wacky math for even wackier physics. The basic idea of this video is that we'll run through a couple of examples in which we'll just take equations and plug in numbers that just don't make sense. Oh, how silly is that? Right? Yeah. Once is by Coast Guard and stuff. I don't know what CB means. I'll be honest. Hold on, let me check if Ali responded to my text. Oh, she did. Well, right when I started the live stream. Oh, damn it. Hold on, Ali. The worst possible time to me. Damn it, Ali! Encoding overloaded, consider turning down video settings or using a faster encoder. No, it's because I'm rendering animation in the background OBS, but thanks for asking. Okay, so, wacky math. How about some wacky math, huh? How about some... I should give an example first. So here's what I mean when I say wacky math. Well, first I could fix my freaking taskbar. That would be a good step one. There we go. And now when I say wacky math, ooh, wacky, silly. I mean relativity time dilation, for example. Equation. Well, what we're looking for. Equation. Oh, I think we have it right there, actually. There. So, the observer time... So, let's take, for example, an equation like this, right? Which is delta t is equal to delta t 0 square root of 1 minus v and c squared. Like this. So, in this video, we'll basically take a bunch of equations like these, and then we'll ask ourselves a question. Now, well, hold on, what if we have a particle, right, going faster than the speed of light. So velocity equal to speed of light plus 1. Isn't that interesting? Well, in that case, we'd have delta t be equal to delta t0 divided by square root of 1 minus c... Wait, c plus 1, no. That would be... Oh, that'd be c squared plus 2c plus 1 divided by c squared. And if we write here divide by c squared, we're going to get this equal to delta t0 square root of 1 minus, and then this gives us a 1 plus, wait, minus all of it, so minus 2c divided by c squared minus 1 divided by c squared. And what you will soon find out is that right here we get delta t0 divided by, these two cancel each other out, and we get negative 2c plus 1 divided by c squared. And all of a sudden, oh no, right here we get, what is that? That's an imaginary number. Oh, how, what insanity, am I right? Yeah, that's... We cannot observe the particle if it's going fast in line. I made 4th highest ranked person in Canada a couple days ago. That is a really fun fact. That's really cool. That is really, really cool. Well, I've met... no one. But yeah, basically this would be the video. Damn it, Ali responded... Alright, that's it. Situation handled. Let's get into it. Initial example. So first, initial example of how we're gonna break physics. I have a phenomenal example for this one, because how are we basically breaking physics? Let's ask ourselves that question. What did we do wrong in this case? Did you ask me make it to play satisfactory with me when 1.0 comes out? Gabriel, ask me when 1.0 comes out. I physically cannot... Oh, that's a mosquito. I physically cannot play Satisfactory 1.0 with you right now. I don't have the game. It hasn't... Ask me then. Then I would gladly play. Probably also with Tefta. We might actually do a bigger server. That would be fun. I don't know the server. I don't know how to set up a Satisfactory server. I'm pretty certain they don't also work perfectly. But yeah. Okay. So... how are we breaking math exactly? Or physics. We're not breaking math actually. We're breaking physics using math. How are we breaking physics in this case exactly? Great question. Well, the way we're breaking physics is that we take something like velocity, we assign it to a number, in this case which is c, and then we can do with this number whatever we want. We abstracted it into a number. So now we get a number, let's just say equal to 1 velociter, a real unit that I definitely did not make up on the spot, 1 velociter, right? And then we can change it up, so we can ask what happens if it's 0.5 velocities, what happens if it's 0.001 velocities, what happens if it's 2 yocto velocities, and so on and so forth. So this action of abstracting something into a number basically allows us to break it. And a prime example... just constant chaos of everyone. I mean, yeah, it would be, but I've already tried that before. To be fair, I tried it a really long time ago. Oh my goodness, last time I tried doing it, it was with Elliot, Crimpy, and Soda. Wow, that was a long time ago. I think that might have been day 40, 30? 16? That was, oh, that was ages ago. We're on day 500. Fuck, I'm old. Okay. Why does math break physics? Yes, so quick intro, and then a perfect example of how to break physics using math we can actually do in Blender. Yeah, believe it or not, Blender actually has a perfect example for what I'm trying to achieve. If we have a cube, right, if we do cycles, if we do GPU compute, if we add a plane like this, and if we set render, then right here we have a cube, and we can give it something like emission of 3. Now, what is... Stop that. It's not rendering properly because I have a separate thing rendering in the background, and for some reason that's taking up all of my GPU resources because apparently my GPU isn't handling well. I'm pretty certain I might have broken Blender ever so slightly a little bit somehow, or another possibility is that my Windows / PC is breaking down. Neither of which are good, so I'm trying to ignore the problem. The point is, right here we have a cube, and what does emission do? Well, basically, emission, we have light particles, because this is ray tracing, so we have the rays. We have the rays, technically they're not coming off the cube, but for the sake of simplicity. We have the rays coming off the cube, right, like photons. They're coming off the cube, like this, and what emission basically does is that the higher the emission, the more rays we have. So, low emission, only, let's give them waves to be physically well, not quite physically accurate, but you know, representation accurate. So, low number of emissions means low number. Then, high emission means high number. Can anyone see where I'm going with this yet? No? That makes sense, I haven't explained it properly. High number. In this case, we're once again doing the thing. We are abstracting a real physical thing. We're taking a real physical thing and we're abstracting it into a number, which allows us to break it. Why? Well, it's because when we abstract into the number isn't tied to the same constraints as the original physical thing. So now we can have it at 1, we can have it at 2, we can have it on 100, which is really, really bright. We can have it on 0, which means no emission. All of these make sense. Or we can have it on -10, in which case it's pitch black. It's more than pitch black. It's actually... Well, what's it doing exactly? Is it... From a physical point of view, if this was in real life, what would like emission of -10 mean? Is it sucking up light? Is it... emitting opposite charge? Is it emitting, I don't know what antiphotons are called, but is it emitting antiphotons? Well, no, it's neither sucking them in nor emitting antiphotons. It just doesn't make sense because we plugged in a negative number. It's emitting a negative amount of photons, not negative photons, an infinite amount of photons. And that way we can break physics. That's just one example. This is the first one which we'll have in Blender. It's pretty simple. I love it. Why does my... Okay. The process is simple, but really how will... So how does it use ray tracing? Well, when it comes to ray tracing, that's the thing. When it comes to ray tracing, it's different. That's because when it comes to ray tracing, it's not the cube emitting the particles. If I do remember correctly, it's the camera emitting the particles. And that way, if it hits an object with high emission, then it counts it as a high, you know, a bright ray. So that way, it is possible to... That way, cube absorbs the rays always. Doesn't matter if they're bright or dark, it always absorbs them. So in Blender, you can absorb positive, like bright photons, and you can absorb dark photons. Dark photons can exist in Blender because the physics is different. But in real life, it wouldn't make sense. That's kind of precisely the point. The math for it would technically make sense, but only because we abstracted it. Hi there, Life, by the way. Damn it, I'm so sorry, Life. You and Happy have both short nicknames and blue avatars with a single letter in them, and my brain sometimes takes a second to, like, realize not the same account. I am so sorry. Anyhow, that's the example. Let's do it. To break physics using math. And for that, we'll use a light bulb. This light bulb, when we turn it on, emits photons. Isn't that lovely? Yeah, it emits photons. In order light. More photons. Bulb. Less photons. Yes. Okay. Simple. Can represent the amount. By the way, I'm gonna be tapping. Let me know if maybe it's uncomfortable tapping it like that. Or should I stop? Should I just chat about something else while I'm typing? Or just no ASMR. Yeah, you know what? Fine. Fine, we're doing the ASMR make it. Should it be make it talking to themselves, ASMR, or just keyboard clicking? Will you be talking about the wackier drive? What is that? You can't just go and drop a big boy phrase like that on me and just expect me to know what... Oh no, never mind, I know this. Okay, call it a warp drive. Everyone knows it as a warp drive. I will be talking about... Well, I know I'll be talking about tachyons, definitely. I don't know if wackier drive... I mean, maybe. Relativity will be fun to break using this, because relativity has a lot of... I did start the live stream by talking about this, which is the time dilation, what happens when some sort of object is moving faster than the speed of light, which gives you an unexpected result, because when you're moving faster than the speed of light, time isn't moving backwards, time is moving in an imaginary way. Because right here, it's a negative number inside of a square root. Not a negative, which I find really interesting. As you can see, it's a minus, but the minus is inside of a square root, which gives you an imaginary number. I do believe you can just bring it out, in which case, unless I am mistaken, this is a separate thing, by the way. Unless I'm mistaken, I do believe you can bring it out, which would give you delta t0 I square root of 2c plus 1 divided by c squared. In which case, I guess c is a constant, so we could just like compute that. We could just compute the value. And then we'll get delta t divided by I and the number. So it would be imaginary. Or at least you'd be dividing by an imaginary. Hold on, would that be... If you have a number divided by an imaginary, you still... I have to... Fine, I have to look it up. I can't let it go. Wolfram Alpha. This entire live stream will be about us having fun with math, so wacky math. What about something you like? What do I like? Good question. I found out recently. Recently I tried socializing some more, and it actually worked for me for the first time in years. It's incredible. X is equal to fraction... Nope, never mind. 1 divided by I. What would it be equal to? Okay, no, that's dumb. Negative I. Color me shocked and surprised. 1 divided by I is also equal to negative I. Yeah, I knew this something didn't feel right. I knew this. Okay, so in this case, we would get this equal to negative. I really hope I'm doing this right. Okay, how about 2i? So 3 is divided by 2i. What do we get then? 3 second I. No, this is as a group. Okay, yeah, so I just jumps to the top. No matter what. Okay, good. So by only I. And we get negative, which means the actual answer would be negative I delta t 0 divided by square root of 2c plus 1 divided by the square root of c. I mean the square of c. Isn't that... okay, isn't that pretty cool? If you have an object going faster than the speed of light, its time isn't going backwards, it's going backwards in an imaginary way. Well, I would have to double check the equation to make sure that's exactly what it means. Exactly, but I mean, the fact you get imaginary number is pretty cool in my opinion. Alright. And so on. Now what we've done. How you say imaginary because you make it sound cool. I mean, it is pretty cool because if you think about this, if we do find a way to travel faster than light, what would this basically mean? What would it mean for time to run in an imaginary, or well, I don't even know how to word it. What would it mean to what would it mean for time to run imaginarily? If it were to just run backwards, that would be simple. If we find... what that would basically mean is that if we find a way to go faster than the speed of light, we can time travel, basically. That's simple enough. But this is not going backwards, this is going in an imaginary way. Well, try to imagine it, not gonna lie. Yeah, it's so complex. Get it, because a complex number, funny. This is technically half a complex number. It's really cool, my point being. 0, which gives us no emission, or negative 3. What would negative 3 mean? Blender, simple. Yes. A light bulb so dark it's sucking up the light around it. Real life, it doesn't make sense. No, it does not. That's... in this case, if this value represents the amount of photons is emitting, is the if this value is the abstraction, always in big letters, it will be important, subtraction of the amount of photons the object is emitting, then a negative value wouldn't mean object sucking in photons or the object emitting antiphotons? What's an antiphoton? I gotta check at this point. Antiphotons. What's the antiparticle for photons? Antiphotons exist. No, is there really no... Oh, Illinois, how convenient. Is yes, but this one uses antiphotons are photons are the same particles. Some particles different other particles. Oh, antiphotons are photons. That's actually really cool and curious. Hi, the ninja. Welcome. Cannot be as well. Anti-neutron is made of anti-quarks, so it is okay. I'm just going to say anti-photons for the sake of simplicity. No, this object emitting normal photons, normal ordinary photons, but a negative amount. The villain is the hero of it. Yeah, I'm pretty certain that's just called anti-hero Deadpool stuff, am I right? I haven't seen Deadpool, no spoilers. Yes, you have. Into chemistry. Then your cousin, I'm so proud to say that doesn't know what is Skibidi Sigma or Ohio, doesn't watch Skibidi Toilet, and doesn't play Roblox. Damn. Okay, let the kid play Roblox. Yeah, I don't think that's a brain rot thing. I just think it's just the game, but not what I'm impressed with the other stuff. I know people who are, well, I'm thinking who is the older person who is the oldest person that ever told me that. I know people who are around 20 years old. And they use Kids Talk, which, well, it's an ick, I would say. Like a red flag kind. So, example. I guess wavelength would be the same thing as energy, wouldn't it? I realized that I got to read up on Spanish orthography once more when taking... What is... I don't even know what orthography means, and you're doing it in Spanish. What is relativistic quantum mechanics? Are they two complete opposite sides of another? Actually not. Well, actually, no. Relativistic quantum mechanics is just like the most advanced science, I would say. I mean, I don't know if it's called relativistic quantum mechanics, but it is relativistic quantum mechanics. I'm pretty Wow, would you look at that? Make it this smart. So basically, when it goes through quantum mechanics, there are certain equations which you really get from relativity. A great example of that would be energy of the photon, which I'm pretty certain has been invented, or at least, you know, made, contributed to, by the one, the only, the man, myth, the legend, your boy Einstein and Planck, the power couple to reinvent physics. And basically, this is based on, well, this is obviously a quantum mechanical equation, right? Because photons, and at the same time, it's relativistic. From what I've seen, at least. Like, on one of the live streams, I tried to get into this equation and figure out why it is what it is, and the deeper you dig, the more you realize it's based on relativity. I mean, obviously, that's a really beautiful marriage of two things, I would say. Just Planck, who is the master of quantumness, and Einstein, who's the master of relativity. Didn't he bloody invent the thing? Wild. The energy of the photons, oh, what else would there be? What else could... Well, no, the amount of photons and their energy, these are the... He's watching English and asking, do you know his thing about... What? I know, looks fun. I mean, shorts do have that property, right? They're meant to be extremely engaging and extremely addictive. For example, each photons, the energy of photons, using the amount of photons, the energy of photons, the density, would that make sense? I mean, kind of, that would be the amount. No, brightness is set only by two things, isn't it? The amount and their energy. Is mostly relativistic. Actually, New Zealand is working on new Half-Life. Wait, what do you mean sort of? They have been working on a new Half-Life for decades. 2004. Nah, what a year. Alright. I know Alex released, but Alex technically isn't, you know, the Half-Life. Oh, it's not the third. And that's what abstraction is about. But this video, I don't want to just talk about these deep meaning topics. That's cringe. This video, I'd like to just have fun. So let's have fun and do some wacky math for even wackier physics. Okay, because the title of this live stream isn't that fun, right? 30 minutes. Fine, let's write the script, whatever. So first, I think we could start the time dilation, actually. And right here, actually, you know what? I feel like 38 stream 552. I feel like we could include this in the video. That'll be funny. Little Ghost made by Louis Zong. Whom? You're gonna have to make me look him up, huh? No. Whom are they? Oh, wait, isn't that the one on the... I think I know him. No, Zone Ghost. Yeah, this is the one that Ali's got in the freaking things. The Ghost Choir. I remember that one. It's these little suckers, alright? I know these. No, he's just like me for real. Okay. Pretty famous. Yeah, I've heard of it. Time dilation. So first... Simple. Something... Relativity! Cool. So, time dilation. Let's go for it. Oh, but how much in depth do I want to go? Not too much in depth. I would just prefer to... Happy, why are you deleting your messages again? If you can delete them, should I even bother responding? Not free as that. That's fair, but what about your other comments this live stream? Alright. Time dilation. I mean, time dilation equation. Not from lecture. Once because traveling in observers, 1%. Okay. So what this means is we need to open up a wiki page for time dilation. Oh, go for it. They give me about his name, that's right. Then don't send them. Read the comment before sending. It really doesn't take much time. Okay, that makes sense. Delta t is equal to 2l divided by c. So, alright, 2l divided by c, because that's how much they traveled in delta t. Okay. This observer, however, measures time to pass as 2d divided by c. That's because they traveled this distance, which is larger. But what does delta t prime mean? Generate time, top mirror b, 1 second time. Okay, so signal returns at time, but for which, for whom? Something that the next time Valve will count to 3 is with Steam Deck 3. That's a great song, by the way. Okay. Second productivity. Laws by which the states of physical systems undergo change are not effective when these change of state be referred to the one or two of the systems from transition relative to each other. First one, light speed. Light is always propagated in empty space with definite velocity speed c, and then the of motion of the emitting body. I'm really curious. Oh, wait, this is postulate. Is it postulate or is it a... Make it, you're getting sidetracked. Time dilation. Yeah, simple stuff, simple video. I really wish Alex was here. Because honestly, I don't have that many ideas for this breaking physics thing. I have a couple. Hold on, let me find the couple before I forget. The couple are time dilation, then after that we'll have negative kinetic energy. Time going backwards, no wait, that's time dilation, yeah. Imaginary mass, so tachyons basically. Okay, so imaginary mass will have two things. First thing will be momentum, and second thing will be going faster than light. 3 charges instead of positive and negative, separating gravitational mass and momentum mass, and that's it. That's all I have for now. May I ask what is planned for 20k subscribers? We already have 20k, don't we? Was I supposed to... We reached that goal, didn't we? Wait, what year is it? We reached that goal, right? It's 2024, I think. Yeah, 20,000. And 6! Because the most recent video just blew up. 30,000, look at that. It's second most famous video. Nothing, probably make it needs at least 50k right now. No, what I need is each video I make to get from 50,000 to 100,000 views in order for this to be my full-time job. I'm not there yet. Like, this video is the second most popular video I've ever made. And if I want this to be my full-time job, it still doesn't have enough views. So, I'm good, I'm fine. Thanks for asking. Time dilation. Some is simple, some complex. Relativity. Time dilation. Exact. Equation. Here's an equation that will just pop in the equation. Yeah, the Lorentz factor. I do remember the Lorentz factor. I just don't remember exactly which time is which. It was on point. I'm good. I'm fine. Yeah, yeah. Come on, it's just that's alright. I'm not worried. Why would I be worried? So, oh, it's a sweet animation. Okay, so the quicker something goes, the slower the time. Here's the equation. Okay, let's write down the equation just to insert equation. The equation will be delta t is equal to fraction of delta t is 0, and then that divided by s square t of 1 minus, if I remember correctly, fraction velocity squared c squared. I have to here say some make it say some brain rot. No, you don't have to actually. You don't have to, you want to, and that means it's not good enough for me to actually say anything. It's not that I don't want to, I just really don't want to. This, and that gives us the time dilation, which means makes sense. It's slower. Okay. What? Nope. Back to 11. This would be the time of our moving cube. So just remember, the quicker we go, the slower it gets. So delta t is the moving one. Oops, this is the observer. Now, if our moving cube is traveling forward at a second, let's take this. If we insert into our equation, just 1 second for observe was, and now we have to calculate it how long it's been for our moving cube, which we're gonna do in Python, because Lord knows I'm not myself. Speed of light, if I may. The ASMR coursing through my veins, yeah. You're welcome, by the way. This is how many meters, okay. C is equal to this. Limit 2 79299. Okay. Now del t is equal to 1 divided by 1 minus 1 divided by c squared. Well, no crap, it's practically 1.0. The problem is I kind of do need the exact value, you know, the exact value, if you wouldn't mind. Negative 17. I wonder how fast can make it type. Not too quickly. I mean, I knew this wasn't gonna be much of a difference. Come on, give me the... Python, get the exact number. Up to however many digits. Up to 30 digits. No, that's not what I'm looking for. Yes, that is what I'm looking for. Let me guess. Why is that picture is so completely unrelated? Decimal module, hell yeah. Oh, sweet. I think that could be jackpot. I'm gonna get milk again. Try to come back this time. I'm gonna go sleep. It's fine, Gabriel. Good night. See ya tomorrow for day 3. Alright. Import decimal. And then what we do is we print the exact same thing. So we do decimal like this, and then decimal like this, and then decimal like this. Oh, hell yeah. And now we can do the full equation by doing decimal 1 divided by this whole absolute mess. I forgot about the square root. I did. Okay, is there another way for me to... Can I get it to a power of -2? Oh, yeah, I honestly didn't believe that would work, if I'm being honest. It is different, okay. Now I can just copy it. Seconds. 7 ... 0.9999999. How many 9s are there? Oh, lord. Okay. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 9s. 99999999999999997 seconds. Slower. Another thing we could check is like negative velocity. Oh, I guess negative velocity is real though, isn't it? In relativity. Wait, wouldn't negative velocity... Hold on. That's a good question. does this work? So if we apply it the other way, then that person is also moving with velocity, actually. Oh yeah, negative velocity wouldn't matter in this case. You have the square, makes sense. Imaginary velocity though would. Imaginary velocity would mean the time would actually increase. So for both of them, the time was shorter than for the other one. Both of them would perceive their time as shorter than the other one. Trippy. Because if we switch these around, right, then if we switch them around, so if we say that this is our observer cube and this is our moving cube, we still get the same result because from the perspective of the observing cube, the moving cube is moving. From the perspective of the moving cube, the observing cube is moving. But first, let's double check. Stationary in quotes, love it. Okay, so I am correct. Cool. This confirms exactly what I've been saying. Good. I'm saying in this case, we could switch around. That's point. The moving cube as Mary. Stay and the end way. So both of these cubes would perceive their own time as normal. 1 second per second, and the others 69s per second. And that itself is already weird enough, but we can go further. Wait, how does it make sense for both of them to? I don't know. This animation is really nice. I don't get it. It's no problem. Time UV of a clock in S is shorter compared to UX in S. UW clock. Oh, I see. Okay. I see. Okay, now I get it. I get it. I get it. I get it now. Because what if this equation, what if we're traveling faster than the speed of light? At the speed of light. Can't really, but we're here to break physics using math, facts, and logic. using math. So, break physics using math. So, hence if I cube is it's getting low each time, correct? Wait, how does that make sense? I don't... Wait, did I misunderstand the equation? Okay, get low each time. Is 1... Did I not divide by 1? Or did I not divide 1 by it? 1 divided by this decimal. Did I screw it up? Nope. Something doesn't feel right. So, the bottom... What we get on the bottom of this equation is delta t, right, square root of 1 minus this. This would be lower than 1 by definition, right? And if there's any velocity, this would be lower than 1. If we take a square root, it still has to be lower than 1. And so if we divide the number, if we take 1 divided by something lower than 1, shouldn't we get a higher than 1 number? I am confused. What happens if we remove the 1 divided by? We get a higher than 1, okay. Alright, why? Squared. Doesn't make much sense, does it? I think I have to remove the square root. Oh! Oh yeah, well, that's because I'm an idiot, that's why. Thank goodness for checking. Yeah, I knew something didn't feel right. You are... No! I knew something didn't feel right. Okay. Moving observer is... moving observer's period of the clock is longer than period t. Not shorter, it's longer. And I have no idea how to do that math in Python because it's fraction. From fraction to fraction, tempting. That's also tempting. NumPy, I'm an idiot, I could do it in NumPy. NumPy should be fine. From NumPy, import NumPy as NP, and then the same exact thing, except we replace each decimal with np.float 64. Point rest, yeah. Do I really have to do it by hand? Why? Why would I have to do it by hand? Well, that sucks. C squared. That's our number. And now what we have to do is we have to do this, well, 1 divided by this, which I'm pretty certain already breaks, right? Never mind! Negative E17, that means... wait, print. Can I print as like a float? Oh. NP float. Whatever, which would... 64. Which will give me the full number. Whatever. Okay, doesn't matter. So, oh, just another idea actually. I suck. How do I display a full number? Because I wanna double check that I'm writing it true, because I'm reason this should mean 17 zeros, correct? Well, easy way to check, I suppose. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yep. So this 1 minus this, so then 1 minus this is practically 1.0, but not exactly 1.0. In reality, it would be in reality, it would be 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. There. Wait, no. There. 1 minus this would be 0. This is 1 minus this. And now all we have to do is just 1 divided by this. Well, I was expecting anything else, honestly, at this point. Decimal saved me. Decimal, you suck. Ah, why have you forsaken me? Can I just remove the print? Decimal 1. No, it's not decimal 1. I beg to differ. It's so very much not decimal 1. No, it's not decimal 1. Calculator sick. Full precision calculator. I'm tired. Okay. Speed of light squared gives us what now? I already forgot. Well, as if I ever remembered. This number is the point. Sweet. So 1 divided by 1 minus, nope, 1 minus, and then 1 divided by this. That's precise. That's kind of what we're looking for. That's so many numbers. 1.0, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Zeros. Dot. Precision, indeed. Hi, Tilly. Precision, indeed. Higher. There we go. Staying. Okay, yes, so the one moving, as we can see. Well, that's the switch. The one moving perceived the time as higher. Did they make it? Hi there, fish. Hi, welcome. How you doing? Welcome to the stream. It's me that make it. The one who makes it happen. Okay, the relativity breaks my brain. It's painful every single time. You can't just wrap your head around it. You need to think about it from all points of view, it's exhausting. Well, physics, you can't really hit break physics using math. So this is what happens if a cube moving one moves at the speed of light. Well, first let's see what happens if we up. Okay, so good luck. Well, thank you, and good luck to you too. This was the comment. There we go. Speed of cube is simple enough, right? We just need to insert right here. 1 divided by 1 minus x squared divided by speed of light squared, which is this number. Oh, I love Desmos. There, now we can see that the further we go, it doesn't really change by much. Yeah, it's not... It takes a while for it to warm up, you know what I'm... you just have to zoom out a bit. Speed of light has 9 digits, correct? Yep. Okay, well, let's zoom back, which I'm certain won't be a problem. Can I do it in plus? Okay, thank goodness. Stay at 0. That's not 0. Stay at 0. That's not 0. Okay, so what we'd like to go is we'd like to... Can I move directly to some place without having to go through this entire process of just very slowly... Right, we're back. Sweet. This is where we want to be. So this is like how the time is behaving, correct? Now... Oh, I can! Sweet. Rounds of increase 19. Ooh, hell yeah. Okay, so we want to go to... From 0 to... Okay, we want from 0 to not to 12, only to 3 for now. There we go, now we can see the time. And we want you to go... to the speed of light, 299,000, correct? 300,000, that's good enough. There, and now we can see that at 300,000 it's just skyrocketing. Oh, I didn't see that before when I was zooming out. Well, good to know, that's what this looks like. Oh, probably because it averages out, yeah, that makes sense. So there. Why is this in the negative, actually? I forgot the square root, that's why. I'm an idiot, I'm such an idiot. There, now it makes sense. What are you up to? Hi there, Andrew. Video, actually, scripting a video. About funky numbers and whatnot. Okay, so there we go. As you can see, we have nothing on this side, and that's because once we reach the speed of light, well, that's kind of the point of this chapter, right? That once we reach the speed of light, then it becomes imaginary, so we can't represent it on just like this with Desmos. But the entire point is, the more we go, the more forward you go. Cute. And we can see that as the velocity of cube goes up, that's the time dilation. So does the time dilation. Nope, Go away, Windows. I don't care for you. And add the speed of light. Well, if we speed of light into our equation, right here, c squared by c squared, which is 1, and 1 minus 1 is 0, and square root of 0 is 0, and 1 divided by 0, that's kind of infinity, which tracks. Here you may say something like, make it, but how could the time dilation be equal to infinity? This doesn't make any sense. That's a completely normal reaction, I would say, that sort of information. Doesn't make any sense. But if you think that 1 second for our cube, 1 second passing cube means an infinite time passing, the other cube is weird, then just wait until the faster than speed of light. Okay. Coffee keeps me going. Let's plug in speed of light plus 1 into our equation. Get this. So right here, this will be right here, c squared plus 2c plus 1, c squared and c squared cancel, we get 1, and call this the y, because why do you care? The number is relevant. And the only thing that matters is end up with an imaginary number. Why? And because of how imaginary numbers work. And if our moving cube is traveling faster than the speed speed of light. Second, it receives the cube, gets a negative imagined amount of time. Let's It's already been an hour and a half. We check it up. To be fair, I really don't know how to describe it. It really doesn't make much sense, does it? It just... No, it just, you know... No, instead of negative energy, let's do negative energies. That'll be fun to push to the limit. This lab actually seems interesting. Oh, does it really? Most of the time I just spend typing in silence, so I'm really glad this seems at least kind of interesting. I mean, the video will be certainly interesting, it's just that it's going to take me at least a week to make. At least. Every single one of these chapters will need an animation. That is at least a week. Which is fun. In my opinion, it's really cool that if you have a cube, for the sake of the argument, you accelerate it to fasten the speed of light, time dilation will tell you that basically from your point of view its time would be negatively imaginary. It's insane. It doesn't make any sense. Like, technically the time would be going backwards, but also imaginary, which doesn't make sense, and I absolutely love it. Hi the Unisoc, welcome, how you doing? How you doing? How's life going? How can I segue this into negative energies? No, really genuine question. How could I segue this into negative energies? Because whilst negative mass make... okay. Time, even this. So that's such a dumb segue. I wanted to do a parody of a segue, so basically no. But for that you need energy. So speaking of a segue and then just doing a segue, so parody of a segue as a segue, but it's dumb. For anyone currently doing drugs, another concept. Oh, that's actually a really good one. And assuming the only people still watching are physics haters or some really, really high high actually every single segue could be like about doing drugs. That would be pretty funny. There's a running bit of the video where from negative energies. Oh yeah, and so now they've probably done probably smoked enough weed. Let's talk about the imaginary mass. Move on to the negative energy. And how convenient. I just happened to have made an entire video about energies. It's about time that we break them. What's happened to my entire video about energies? So it's about time we break them. Let's pick a couple fun ones. Like, will be good fun energies to break. Kinetic, radiant. Radiant or radio? Radiant, right? Not radio. It is radiant, good. Kinetic, radiant, thermal. Thermal will be good, but thermal will be good after kinetic. Any other energies to break? I should do rule 4, right? Well, rule 3 I guess also works. Kinetic, thermal, radiant, potential, gravitational potential, maybe. I mean, okay, electrical is kind of a adopted cousin of the energies, so I don't think electrical would fit in. Because electrical, to be fair, electrical would be more akin to thermal in this case. So thermal is just kinetic, except statistical kinetic, and electrical is just statistical kinetic plus charge. So I feel like we should just go radiant and gravitational potential. Kinetic. Described with the equation of, if I do remember correctly, that should be E is equal to m fraction of time, no, distance squared divided by time squared. Because if I do remember correctly, it's momentum times velocity. Right. And so the basic idea right here is that we plug in a negative number for the energy and we see where it leads, which would have to be imaginary mass is next. Actually, we should start with kinetic. We shouldn't start with kinetic, we should end with kinetic. Radiant. Kinetic. So first, what is thermal? Yeah, we're going to pick the simplest thermal energy, which is basically the ideal gas law one. The ideal gas law one is just kinetic energy times the amount of things it applies to. So thermal energy Editions on the system. Oh, what's the... Yeah, customer small question. Yeah, I think it's microscopic then. Is it? Oh, internal energy. Right, now we have to pick the right one. I do believe there was a table for them. Ta, fun! Partial derivatives, my beloved. Is my music breaking? Oh, it is. Blender is really struggling at the moment. What fields and subfields do you find most interesting? I find all of them interesting and I love them all, but I do find them interesting in different ways. Relativity is my new favorite. Well, not new favorite, or new one of the favorites, as I mentioned. But I love relativity because it's general relativity, because it's so unbelievably bizarre. It's basically assuming we know nothing, and solution to us knowing nothing is to make no assumptions, and I absolutely love it for it. It's great. Chemistry. For chemistry, quantum chemistry is really pleasant. It explains a lot of daily things really well. It's really pleasant. But electrochemistry is really fun practically wise, and organic chemistry makes fun things, so I do like those two. Then we have, well, relativistic quantum mechanics. That's kind of the main thing physics wise, I suppose. Right, this is kind of my biggest video on the channel is precisely about quantum mechanics, so it's the obvious pick. Recently I'm getting more into practical aspect of science. So electricity is really fun. General chemistry, also bringing in that one. It's hard for me to pick a favorite. I love them all. It's like picking your favorite kid. I can do it. Even if I had a kid. Maybe I do have a kid. Oh, what a terrifying thought. I got sidetracked. I started thinking about a different thing. What was I mean, I can just check the script of the energy video, I suppose. There we go. Thermo. What do we use? Thermo? Nope, wrong. Thermodynamics. I just realized the energy video was the last video before the 7-dimensional one. It got less than 3,000 views. Ooh, not a lot. PV is equal to NKT. Thank you. That's exactly what I'm looking for. PV is equal to NKT. So, asking is thermal energy is asking by saying what this negative energy is. What does NKT being equal to negative mean? Oh, K is a constant, isn't it? So it's just N times T. No, thermal is boring. Thermal is so boring. We're not doing thermal. Never mind, take it back. Thermal is actually really boring. Radiant. So what is radiant energy? Radiant energy can be described using equation of, and if I remember correctly, it was E is equal to H divided by C, if I think. But I wouldn't put my money on it, because I don't trust myself, so instead we're just gonna look it up. Nope, nope. Relativistic energy momentum, hell yeah. Energy and momentum fallen can but only as frequency or invisibly as well. Like, okay, so energy looks like momentum times the speed of light, which is this. So h nu, or hc divided by lambda, which I think is much easier. hc divided by lambda. This case. First, oh, actually not A. No. First. Different universe. Which doesn't make much sense actually for the Planck constant to be negative, so we're gonna skip that because that's really boring. Just switching a constant. In that, if that was the case, then the universe would just be different, and that's it. That's the entire explanation. Which, I mean, I guess I could go to some conclusions over there, but speculating over what that universe would look like wouldn't be that interesting, because we would switch a negative for one thing, and that negative would then just switch all the other things to negative, which means negative would be the new positive. Not interesting. Make it, what's your opinion on the idea of entropy? I don't think it's an idea, I think it's just a thing. It's kind of like asking Make It, what's your opinion on the idea of energy? Actually really close, because they're both tied up together. You mean what's my opinion on the idea of, or what's my opinion on entropy? Because my opinion on the idea is that, yeah, it makes sense. I don't think that it always increasing. My personal belief is, that's a belief, personal belief, which is not supported by evidence, so I don't think that's the case right now. I don't think that's the case, but I do believe, hold on, it's not supported by the current theory, but I do believe that to be the case once we find a way. I don't think it's always increasing. I do think that there would be a way to decrease it, we just don't know how. So using new science. But that's it, that's all I think about it. I just think it could be decreased using science we haven't discovered yet. Or hope. It could be decreased using science we haven't discovered yet. I guess hope would be the better word for it than think. Yeah. What was I checking? Yeah, Planck's constant, that's right. So Planck constant, I'm not gonna check what Planck's constant would be negative. Second, which is speed of light, would be negative. Or third, wavelength would have to be negative. Like, what's your opinion on the idea of mass? I love the relativistic thing with gravitation and momentum one. Just great. I know they're equivalent, but I just find it's really cool. Right here we'll have separating gravitational and momentum mass as the last chapter. This entire video, I just realized, is about relativity. Time dilation, energy of a photon, imaginary mass of going faster than light, yeah. Well, free charges is different, but separating gravitational mass, momentum mass, that's relativity. It's kind of boring. Just what? Look like? Well, it means an object either going and negative this, going back in time. This not mean backwards. No. It means forward, just a negative number of meters. Happy, what did you just say? Happy, I don't think you understand what relativity is. Negative number of meters. So going not as easy as you think. Sick. Maybe something else. So the last part and the first part was confused rambling. So thank you for deleting the messages. Now I can't even clear up which part you're talking about. Swell move. Negative force is not easy as you think. Okay. Okay, what about time with what would negative wavelength even be? Wait, hold on. Wavelength. Ah, that's curious. When you have a wavelength, it is just a distance like this. So what would negative wavelength be like? Which wave shape repeats? is distance between consecutive corresponding points the same phase away. It's just two adjacent crests. What is your crossing? Because mathematically, purely mathematically, negative wavelength would just be the same as positive, right? Like this can be either told as lambda or negative lambda. There's an equation for a wave, right? If I'm not mistaken. Yeah, this. In which case, k is equal to 2 pi divided by lambda. Yeah. That's exactly what I'm looking for. So let's... Actually, no, I'll bring this back. Let's Desmos the sucker. Relativity is more than just a time travel thing. I mean, I actually don't think you can time travel in relativity. I mean, maybe with the gravitational time dilation? I should check that out, gravitational time dilation. I really should. That's what we'll do right now. No, I don't think so. In order to time travel, you would need this to be negative. That's what you need in order to time travel. Well, unless you want to time travel forwards, in which case, well, just wait. But to try time travel backwards, like we all want, this would have to be negative. But this can't really be negative. It's a square root. In order to get... And so getting a negative number out of a square root, a bit of a challenge. So actually, don't know any way for anyone to time travel with relativity. There probably is something. Alright, Desmos. Cosine of kx minus... Actually, nothing, we don't care about the other one, the other one's for time. So kx, other slide the k will be equal to fraction of 2 pi divided by lambda, and then other slide the l, and there we go, we have l. And which is negative, yeah, it's the same exact thing. Hey, make it, is it badly comments? It's, well, it depends on the definition of bad, I suppose. It just shows that you're not thinking about what you're saying. If you have to delete your message, that means you didn't think before sending it. Basically what it means. At least that's how I perceive it. The radio, it also sucks. Which... need... I got a text. Is it my bank or no? That's just cool. No, that's my phone letting me know that it's about to die. Sick! Eat. Well, I guess thanks for letting me know. There. Have the cable. Have some charge. Okay. It's already been 2 hours. Oh gee whiz. Fine, if you I get the man to travel back in time. Because negative way. Wavelength could be. Right, just a double check as a sanity check. It is the same as positive, correct? If we take this and if we do negative kx, then they are completely overlapping. Shocker. It's the same as positive. So what could actually have negative rate energy. And back to 11. That's no wait, it's actually I can beat you. What is the potential energy, gravitational energy equal to? Yeah, equation. Yup. GMM divided by R. Wait, displacement vector between the particles. Wait, R or. Hold on. R squared, there we go. That's the, wait, no, that's the force. But. Okay, energy is force times displacement, which means the energy is just this. With an. I'm sorry? The gravitational of all simplifies to potential energy U. This is negative. I'm sorry, negative? Gravitational constant. which is a positive thing. We have the gravitational constant, very much positive. Multiplied by mass, which is positive. Multiplied by mass, which is positive. Divided by r, which is the displacement vector between two particles. Okay, why is this negative whilst this is positive? Why is this negative? Why is this negative walk? And all of a sudden, what's happened? Hold on, Newtonian mechanics. That's much simpler. Give me something simple. Force, which is equal to this, makes sense. In which case, walk is okay. Yeah, that seems simple enough. Negative. When did negative sneak in? Oh, there it is. My beloved. Okay. Negative. Okay, maybe makes sense. It might make sense. Maybe. Okay. Negative. Why is it negative? I've been trying. Hold on. The entire chapter is about breaking physics. Well, the entire video is about breaking physics in math. And the entire chapter is about negative energies. And you mean tell me that gravitational potential energy is already negative? Why is it negative? I must be missing something. Delta U. That makes sense. The higher the... No, wait, what? Hold on. So R is the distance. Okay, let's check it. Let's check it. Let's see how it looks. Is it because when you... Okay, I have one idea of why this would be negative, actually. We have one object right here and one object right here. In this case, between these two, we have top, which will be constant, divided by r. Right? Negative r, so this is the energy of this one. And then right here, we have distance h. So the energy of the x0 is this, energy of x1 is constant, because they have the same mass, minus r plus h. Now, which one is greater? Well, if we check it, then we get a negative CR plus H. I'm getting kind of tired, so yeah, we really do have to do it step by step. And they're both negative, which means the lower one will be actually higher if we ignore the sign. So which one is the lower one? Well, this one's the lower one because it has the... Yeah, so this way. Which makes sense. Actually, yeah, makes a lot of sense. Which means, yeah, remember when I mentioned that there might be one way, I think this, yeah, so that one way is basically where you define the ground. So that would be the energy in relation to ground. So there is no potential gravitational energy, there's just potential gravitational energy in relation to other potential gravitational energies, which would be the difference in energies, the difference in potential gravitational energies, which is what we actually care about because we want the ball to roll down the hill. I'm really tired at this point. We'll pick this up tomorrow. Anyhow, that was it for the walking live stream. We're back to the walking live streams. Isn't that fun? Anyhow, I suppose for now, that'll be it. Thank you everyone so much for watching and have a great day. Bye.